Good morning, all the participants in this Janaganit session on EBCD math. As we have discussed in the last session, EBCD stands for everybody can do math. And these sessions are about doing math. I would like to, right at the beginning, emphasize a couple of points. The first point is that this is not an online course. Online courses are places where you listen to lectures or watch some videos. I am not here to give you a lecture or to show you any video. What we will be doing in this session and in all the sessions is we will be doing problem solving. I said we will be doing problem solving, but actually I meant that all the participants will be solving problems. I will be giving problems one by one, and you will solve them by doing, by making. For today's session, what you will require is graph paper. You will require a scale. You will require a protractor and a sharp pencil point. All the activities that we will do today are based on just these few pieces of equipment which you should have. If you have not brought the graph paper, I would request you to please take a minute and come back with some graph paper. I will take a minute's pause while you collect your graph paper for those who have not yet collected the graph paper. Okay, thank you. Now let us begin with the first activity. You take the graph paper and this point here on the left-hand side bottom, call this point as O. Call this point here as O. Is it done? The next activity you have to do is to take your scale and measure the points along this line, the lowest line, which we call the x-axis. Hold your scale next to the x-axis. And you will note that these points here, all these points are separated from each other by what distance?
1 centimeter.
By 1 centimeter. That's right. So now the graph paper and your scale are both matching. And we can use the graph paper as a scale. Or if you don't have graph paper, you can draw lines and measure centimeter lengths. So now we have the points here 1, 2, 3, 4, 5, 6, all the way. As you note, there will be around 19 points along the x-axis, and there will be around 28 points along the y-axis, including the origin. So are we ready to go to the next activity?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now what we have to do is to start at O
त्याला पिन कर सर
and take 3 steps to the right
आणि आवाज मोठा कर आणि हे
and call that point
ते कर नाहीतर
P.
Can you please repeat?
Sir, I can't
Okay,
see.
I will repeat. Start at O and take 3 steps towards the right. 3 steps meaning take 1 centimeter, 1 centimeter, 1 centimeter, and call that point P. Done?
नेटवर्क पाठवलेलं तुला तू बनवले असेल तिचं बोललेलं बनवले नाही मी पण तिला बोलून पाठवली नाही मला नेटवर्क यायची कसं एवढी एवढी बघ अगं ते तुझ्यासारखं नाही फरक करत का खाली बघ कोटकला काय पाठवले
Host or co-host can mute everyone.
Okay. I request all the participants to please mute your mics because we have a very large number of participants. And whenever you want to ask a question, at that point only you unmute. Otherwise, please keep your mic on mute. Now, we've done the first activity, which is to get the point P. Let us go to the second activity, which is to take 7 steps to the right from the origin. 1, 2, 3, 4, 5, 6, 7. And we get a point here, which we will call Q. Done?
Yes, sir.
Yes, sir.
Okay. Now the next instruction is
Yes, sir. Done.
you take 7 steps to the right and 3 steps upwards. And you get this point here, which we will call R. Now we have these 3 points, the point P, the point Q, and the point R. Now, please note what I'm doing. I've taken 7 steps to reach R. 1, 2, 3, 4, 5, 6, 7, 7 to the right, and I've taken 3 steps to reach R upwards. 1, 2, 3. So I will say that the coordinates of this point are 7 and 3. 7 means 7 steps to the right. 3 means 3 steps upwards. So 7, 3 means 7 sideways and 3 upwards. So the coordinates of R are 7, 3. Got it?
Yes, sir.
Yes,
Now-
got it.
Yes.
Yes, sir.
Yes, sir. Yes, sir.
Sir, got it.
Sir.
Now my next question is,
Yes.
if this coordinate is 7, 3, tell me what are the coordinates of the point P?
3 0.
3 0.
3 0.
3 0.
And 3 and 0. Very good. That's right. Because I have to take 3 steps to the right and no steps, 0 steps upwards. So this is 3 0. What are the coordinates of the point Q?
7
0.
7 0.
0. 7 0.
7 0.
7 0.
7 0.
What?
Has everybody understood this?
Yes.
If there is anybody who has not understood it, please raise your hand and ask your question. If there is anybody who has not
Sir, I didn't
understood this,
understand
please raise your hand and ask the question.
Sir, I didn't understand this. How did you get the 701?
Okay. The question is, why did we get 7 0? We got 7 3 because we took 7 steps to the right. 1, 2, 3, 4, 5, 6, 7. That is the first 7. And how many steps up? 3. 1, 2, 3 to reach R. So we
Yes.
write 7, 3. To reach P, I have to take 3 steps to the right and no steps, 0 steps upwards. So this is
Yes.
3 0. To reach Q,
मेरा वाला यूज करना ना तो
I have to take how many steps to the right?
7.
7. And how many steps up? 0.
But we
That
have
is why
taken 3 steps up,
This
right?
is 7, 0.
Yes, but we have taken 3 steps up, right?
Yeah, the participant, we have taken 3 steps up for the point R. We are talking about point Q.
Yes, but we started from point Q, so point Q would not have 7 0.
We start from 0.
3 steps.
We always start from 0.
Yes.
Sir, I can't hear you.
Sir, go ahead.
Yeah, just give us 2 minutes, sir.
So then if we started from Q to reach R, then the 3 steps that we took to reach R won't count for Q, right?
Hello, can you repeat your doubt again?
From 0, from O, we started, we took 7 steps and reached Q. So that's why Q will have 7
we took 7 steps, but then we started from Q to reach R. So then the 3 steps that we took to reach R won't count for Q, right?
Yeah, see, every point has its own coordinates. Let's look at the point P. We always start from O. To reach P from O, we take 3 steps to the right and no steps upwards. That is why we have 3 and 0. To reach Q from O, we take 7 steps to the right and no steps upwards. That is why
Understood, sir.
coordinates is 7, 0. And to reach R from O, we have to take 7 steps to the right and 3 steps upwards. That is why the coordinates of R are 7 and 3. Shall we go to the next question?
Yes, sir.
Yes, sir.
The next problem is, find the point S which has coordinates 3, 3. I'll repeat. Find the point S which has the coordinates 3, 3.
Done, sir.
Yes, sir. Found it.
Done, sir.
Done, sir.
Done, sir.
Now I will do it here on the whiteboard. I start at O. I take 3 steps to the right because 3, 3. 1, 2, 3. After the comma again is 3. So I have to take 3 steps up. 1, 2, and 3. And this is the point S. So now if you have done that on your graph paper, my next question is, and the next problem is, what is this shape that we have created?
A square.
PQRS.
A square. A rectangle. A square.
Is it a square? It's a rectangle.
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 What are the sides of this?
4 blocks and 3 blocks.
4 by 3 square. 4 by 3 rectangle.
This is 3.
Rectangle.
This is 4 centimeters.
4
This
by
is 3 centimeters. So this is a rectangle.
It is a rectangle.
The rectangle with sides 3 centimeters and 4 centimeters. Below 3.
So you have to mark the rectangle.
We will call this by 4 rectangle.
Excuse me, sir. I have to call it as 4.
3, 4. Okay, so we go to the next problem. Your next problem is measure the distance from P to R. Draw a line PR.
काय करायचं जॉईन ओव्हर इंटरनेट करायचं
Draw the diagonal
It is
PR.
5 centimeters.
It is 5 centimeter.
Yes, sir, it is 5 centimeter.
Yes, sir. 5 centimeter. 5 centimeter.
Okay, so I think all of you have measured
It
that.
admit 5 centimeter.
It is 5.1 centimeter.
5 centimeter.
Somebody got 5. Somebody got 5.
Look.
Okay. Most of you, I think, have got 5 centimeters.
Yes, sir.
All right. Now let us go to the next part. This completes the first part. Let us go to the next part. The next part is, on your graph paper, you draw a rectangle.
Sir,
Yes.
sir, my line is 5.1 centimeter at diagonal.
When you measure something, it's always a little here and there. Somebody may get 5.1, somebody may get 4.9, some may get exactly 5.
Sir, even
an
I
actual
had a
measurement-
doubt.
Yes.
So when we measure something on a scale, there is a line which has no, which is 0, and there's a then there's 1. So when we measure, we have to start from 1 or 0.
Do you start from 0 or do you start from 1? If you
Both
start
is
from
okay.
1, then you should reach 6.
Yes. Okay, understood, sir.
Understood? It doesn't matter where you start. If you start from 0, you will reach 5. If you start from 1, you will reach 6. Okay,
Okay, sir.
fine. Let's continue. The next part of the problem is, draw on your graph paper any rectangle of your choice. It doesn't have to be 3 by 5. It should not be 3 by 5. It can be 2 by 4. It can be 3 by 4. It can be 4 by 5. Whatever you want. Draw a rectangle and draw its diagonal. Here in the studio, I will request our participants, Nandita and Preeti, to draw their rectangles.
पता नहीं कहाँ है ले जल्दी चल
All the participants, wherever you are, please draw rectangles of your choice.
Anywhere on the graph, right?
Using your graph paper.
Done, sir.
Done, sir.
Also draw the diagonal.
Done, sir. Yes, sir, do it.
Done, sir.
Okay.
Done, sir. Done, sir. Done, sir.
Have you drawn the diagonals? Measure the length of the diagonal. Measure the length of the diagonal.
Done,
And don't
sir.
tell me what it is.
Sir, measured.
Just write it down on your piece of paper. measure the length of the diagonal. After you have drawn the diagonal, measure the length with your scale. Have you done that, Nandita?
4.
Have you measured? Okay. What rectangle have you drawn?
4 centimeter by 6 centimeter.
4 centimeters by 6 centimeters. And is your diagonal, Nandita, is your diagonal 7.2 centimeters in length?
No, actually 7 centimeters.
Measure it accurately. If it is 4 by 6, you said, right?
Yes, sir. A 4 by 6 rectangle has to be
It is 7.2 centimeters.
Even I got 7.2 centimeter.
What did you get?
Even I got 7.2
7.2 centimeters.
triangles.
Okay, Preeti,
Sir, I
what was your rectangle?
2 centimeters by 5 centimeters.
2 centimeters by 5 centimeters. Okay, I will tell you what is the length of your diagonal. Okay? Two by 5.
Yeah.
Is it about 5.4 centimeters?
Yeah.
It is 5.4. Okay. Will any of the participants tell me what rectangle you have drawn?
6 by 5.
Sir, it's 4 by 8.
5.
By 5.5.
5 by
4
2.
by 5.
4 by 6.
5 by 2. 4 by 8.
5 by 8.
Okay, let us take 5 by 8. Okay. Who drew the rectangle of 5 by 8?
2.
5 by 8, who drew? Which participant drew a rectangle 5
Chetan
centimeters
Gandharva, sir. Chetan
by 8?
Gandharva.
Okay. Chetan, now I'm going to tell you what is the
Yeah.
length of your diagonal. Don't tell me.
5.8.
Oh, please don't tell me. Your rectangle was 5 centimeters and by 8 centimeters, right?
No.
So what was your rectangle, Chetan?
2 minutes. Length is 6 centimeters.
6 centimeters and
Yes.
height?
Height is 2 minutes. 3 centimeters.
The length is 6 centimeters and the
3,
height
3.
is 3 centimeters.
Height is, yes.
Okay. Now,
Diagonal.
let me, no, don't tell me the diagonal. Let me tell you what is your diagonal.
5.8
I
centimeters.
will tell you. I will tell you. Don't tell me.
Okay.
Your diagonal should be 6.7 centimeters. Please measure it.
Yes.
Excuse me, sir. My also 6.7 centimeter.
It is 6.7 centimeters.
Sir, I
Right?
think I got your formula.
No, sir. 5.8.
So I have 1/26.
Just a minute, just a minute. The person who has a diagonal as 5.8 centimeters, tell me the sides of your rectangle.
3 by 5 centimeter.
3 by 5. Okay, let's check.
Three by
You should
five.
get, if it is 3 by 5, then your diagonal is 5.8 centimeters.
Yes.
Right answer, sir.
Okay. Now the
Okay.
question is, how do I know the length of your diagonal when I have not measured it myself? That is what we are going to discuss now.
Sir.
How I can guess the length of your diagonal when you tell me the length of each side of the rectangle. Okay? For the next part now, this is part 2 of our discussion today. For the next part, please take your mobile phone calculator. Please take the calculator on your mobile phone.
Yes, sir. Taken.
Taken, sir.
Sir, taken.
Yes, sir. Taken.
Yeah.
Yes, sir.
Now we are going to do some experiments on the calculator.
Can anyone hear me?
Yes, you are audible.
Sir, taken.
Okay. Please turn on your calculator.
Yes, sir.
Done?
Yes, sir.
On your calculator, do the multiplication 8 into 8.
64.
You don't need a calculator for that.
64.
You can do it mentally.
64.
Very good. Very good. Okay. Now the next one, this is called 8 squared. 8 into 8 means 8 squared. We call it 8
64.
squared.
8 square.
All right. Next problem. Now do 10 squared. Very easy.
64.
Okay.
100.
10 squared. 100.
100.
Okay. You might say, we are giving such easy problems. Why do we need a calculator? All right. Next problem is do 14 squared.
196. 196. 196. 196.
196. Right?
196.
Okay. Let's go on to the next problem. You have done 14 squared, which is 196.
Yes.
And you have done, now you have to do 15 squared.
225.
225.
225.
225.
225.
225 is the square. 225.
So it's very easy to do squares on the calculator.
225.
Yeah.
245.
245.
225.
225. Yes. Now I want to ask the reverse problem. Take the number 225, which is the number when multiplied by itself, which gives me 225.
15.
15.
15.
15. 15. 15.
That's right.
15.
Right? I'm going to ask the question now to Nandita and Preeti. Which is the number which multiplied by itself gives me 144?
Sir, can I tell?
12.
12.
12 into 12 is 144.
12. 12.
Let's make the problem a little bit more complicated. That's right. 12. The number which, when multiplied by itself, is 144 is the number 12. Now, my next question is, which is the number which, when multiplied by itself, gives me 729?
729. Oh, 27, sir. 27. 27. 27. 27.
Let us see how we get 27. Okay, now you repeat what I am doing. Take 729 in the calculator and let me divide it by any number. Let me divide it by 15. What do I get?
125.
48.6.
48.6.
28.6.
48.6.
Now, some of you may not have studied decimals. So what is that 0.6? What is that? We will study later. But anyway, if I divide 729 by 15, I get a number which is near 48. Okay? It's bigger than 15. Now I want to get the number which, when it divides 729, gives me the same number. So let me increase 15. What shall we increase it to?
27.
20. Let's try 20. Let's try 20.
20.
Let's try 20. 729.
This is 145.
36.45.
729 divided by 20
25.
is 36. Again, bigger than 20. Okay, so let's try the next number. 25. Let's try 25. Right?
29.16.
29.16.
29.
29 and 25 are close to each other. Okay, but I need to increase 25. So let's try 26.
28.038461538461158.
I don't want all those decimal points. So if I divide by 26,
27.88.
I get 28 plus something.
Yes, sir.
Right?
Yes,
Very
sir.
close. So now let's go to the next one, which is 27. 729 divided by 27
27.
27.
26.87.
Right. So I hit upon the number which, when multiplied by itself, gives me 729. You got the method? Now I'm going to give you.
Sir, can you repeat?
Sir, please repeat.
Okay, let us repeat. This is a method for calculating that number which, when I multiply it by itself, gives me 729.
Sir, but we knew it is 27, so we took the number, we increased the number, but if we don't know the number, how do we do it?
Right. I'm going to give you a problem now where you don't know the number. Okay.
Sir, we have to always do it with a trial and error method, right?
How we do it by the trial and error method, I'm going to now experiment with. Take the number 1521 and let's follow the same method. Let me divide 1521 by 27. We get 56. Okay? Just look at the whole number part. If I divide 1521 by 27, I get 56.
Yeah, 56.
So now let's increase. What shall we try?
Sir, but why
35.
do we have to increase the number? Why don't we decrease it?
Let us try 35. 1521 divided by 35.
43 point something.
Sir,
43.
43.457142856.
So 35 into 43 is close to 1521. But I want both the numbers to be the same. So I will increase 35. Let's try
36.
37. Niti and Nandita say, let's try 37.
41. 31 point something.
We get 41.
1.108.
Becoming close. Okay.
13.
So now what shall we try? 30?
38.
38. Let's try 38.
Sir, it's 40. 40 point.
1521 divided by 38.
Sir, repeat. Sir, please repeat. I don't understand.
0, 2, 6, 3.
When I divided by 35, we got 43. I want the number by which I am dividing to be equal to the answer. But if I divide by 35, I get 43. So I need to increase.
We should divide by 34.
We should divide by 34. Try.
39. We should divide by 39. 39.
40. Can we try 39? 1521.
Yes, sir. It comes the same answer. 39. 39. Yes, sir.
Yes, sir. Sir, we should divide it by 39 so that we get the same number.
Right, we get the same number. If I divide by 39, we get the same number.
Yeah.
So we have found the square root of 1521. Square root of 1521
Yes, sir.
is 39.
39 square.
39 squared is 1521.
Sir, I have a doubt.
Yes.
Sir, I wanted to ask that why don't we decrease the number? Why we always increase the number?
Sir, may I answer her question?
Yeah, please answer it.
Tanisha, because if we take a smaller number, the square will be small. And if we take a higher or bigger number, then the square will be double of that number. So
Yes, but to find the number, why do we always increase the number? Why don't we decrease it? Like how do we know that it is always the bigger number?
That's a good question.
Because
let me answer that question. Okay. Supposing I took 1521 and I divided by 41. Do that.
37.
37.
Which number?
37.
1521 and I divided by 41. I get the answer as 37. So it means that the number is too big. So now I will have to reduce it. So let me try 40.
How do we know that the number is big?
Because I get 37 as the answer.
Okay.
Okay. When I divide by 41, I get 37 as the answer. I want both the answer and the number by which I am dividing to be the same. So if it's 41, I get 37. 41 is too big. I have to reduce it. I divide by 40. Let's try it. 1521 divided by 40. I get 38. We're getting closer. But I still have to reduce it. So let's try 39. 1521 divided by 39. I get 39.
Okay, thank
So
you.
we have reached the number that we are searching for.
Hello. Hello.
Okay. So now we know how to get the square root of a number. Any other questions?
No, sir.
Shall we proceed?
Yes.
I have a doubt.
Yeah, please ask a question.
Sir, why do we call it a square root?
Why do we call it a square root? It doesn't matter what you call it. Okay, we could call it a square branch. As long as you know what you're doing. It is the number which multiplied by itself gives me that number. Square root is only a name.
Sir, why do we call it square?
Why do we call it a square? That we will see in another discussion when we do a future session. That's a good question. Why it is called a square?
Sir, example 144 root 12.
Square root is 12 and 12 square is 144.
Yes, yes.
Okay.
Okay.
Now we go to part 4 of this discussion. Part 4 of this discussion is make a square on your graph paper. Make a square on your graph paper.
How much centimeter?
Which has side 10 centimeters.
Sir, please repeat the question.
Make a square on your graph paper. I will draw that square on the graph paper here on the board. Okay? I start here, count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, have you gone the square?
Yes, sir.
Yes, sir.
Yes, sir.
Now draw the diagonal
Yes, sir.
and measure its length.
14.1 centimeter.
14.1 centimeter.
14.1 centimeters.
Sir, it had been 13.4 centimeter.
14.2 centimeter.
Please, those who got 13.4 centimeters, please check the sides of your square.
Sir, please repeat.
Preeti, what did you get? 14.2. 14.2. Nandita, what did you get? 14.2. Okay.
Sir, 15.9 centimeter.
Sir,
How much did you get?
15.8 centimeters.
14.2 centimeters.
hello.
Whoever got 15.8, please measure the side of your square.
Sir, 13.4.
Whoever got 13.4, please measure the side of your square.
मुझे लगा आप फोन के इंटरनेट के बारे में
14.2.
Fourteen point two. Who got 13.4?
Chetan.
Please measure with a scale the side of your square. No, the person who got 13.4, 13.4 as the answer. Others don't need to measure. But whoever got 13.4 as the answer for the diagonal, please measure the side of your square.
14.1.
14.1. Right.
Yes.
Not 13.4. Anybody got 13.4?
Diagonal. No. It's my wrong answer.
Okay. 14.1. That's right.
Yes.
All right. Now I want you to do the following. The side of the square is 10.
I think
Each side is 10.
to be 14.
Okay? Just keep that in mind. Now take a fresh graph paper and draw a rectangle with sides 8 and 5.
So can you repeat?
Take a fresh
So 9.5.
No, please listen to what I'm saying again. Okay?
9.5.
No, I'm not asking you to go further.
Okay.
Please listen again. Take a fresh graph paper and draw a rectangle which has one side as 5 and the other side as 12. Earlier I said 8, I correct myself, I'm saying 12. One side as 5, the other side as 12 centimeters.
Sir, drawing.
Have you done it? Yes. Now measure the length of the diagonal.
So 13. Sorry.
13.
So 12.9 centimeter.
12.9, which is almost 13.
Yes, sir, 12.9.
Okay.
Yes, sir, 12.9. Sir, 13 centimeter.
Right. 12 centimeters, 5 centimeters, and the diagonal is 13 centimeters.
Yes, sir, 13 centimeters.
Okay. Now, take a pencil and paper and see what I'm doing. I'm drawing that rectangle here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Eight, 9, 12. So this is the rectangle that you have drawn. This is 5, this is 12, and this is the diagonal. We measure this as 13. Now take your calculator, calculate the square of 5. You don't need a calculator.
25.
You know it is 25.
25.
Calculate the square of 12.
144.
144. Perfect 14.
144.
144 is 12 squared. And calculate the square of 13.
169. 169.
169. Okay. Now let me add these two numbers, 25 and 144. What do I get when I add it?
169.
169.
169. Okay. Let's come here. This first problem. This was a rectangle with side 4 and 3. So let me take the square of 3.
9. 9.
9. Let me take the square of 4.
16.
16.
Let me add them up.
25.
25. And what was the diagonal here? 5. So that is 5 squared.
25.
Okay.
Okay.
So there is a relationship between the square of the diagonal and the squares of the sides of the rectangle. And what is that relationship? I calculate the square of one side.
The relationship
I calculate the square of the other side.
equal to c square.
I add the two squares and I get the square of the diagonal. In a rectangle. Now let's apply that same principle to this square which we had made earlier. One side was 10 and the other side was 10.
Yeah.
Okay. So what is this squared? What is this side squared?
100.
100.
100. 100.
What is this side squared?
100.
100.
100.
I have to add that.
200.
200.
200. And now I have to find the number which is, when I multiply it by itself, I get 200.
100. 100.
Which is the number which, when multiplied by itself, gives me 200.
100.
100.
100 plus 100.
No.
Sir, actually there is no number that can be 200. So you take the rounded off square, which is 196, which is 14 square, and there will be 4 numbers remaining. So 14.4 should be the correct answer.
Okay, so one of the participants says that 14.4 would be the correct answer. We should get 200 if I multiply 14.4 by itself. Please take your calculator and check.
The numbers after the decimal point are.
Sir, it is wrong.
So, 14.1 is the wrong number.
7.36.
Okay, let's now one of the participants says that 14.4 multiplied by itself gives me 200. Let's try that. 14.4 multiplied by 14.4. What do we get? 207. So 14.4 is too big.
So we can divide it by 14.
14.
Sir, 14.14 is the nearest answer. The answer is 199.90.
So let us now try 14.
So 14.2 also.
14 into 14 is 196. That is quite close to 200. Somebody said 14.2. Let us try 14.2. 14.2 into 14.2. That is 201.64. That's quite close to 200. So now do you know why you got the diagonal as 14.2 centimeters?
14.1 into 14.1.
Right, but with your scale, you measured this diagonal.
Sir, but I got the measure as 14 centimeter. I didn't get it 14.2.
Right, when you measure diagonals, somebody got 14, somebody got 14.1, somebody got 14.2. Because when you measure, there is always an error of plus or minus 1 millimeter. Okay, so the answer could be 14.1. It could be 14.2. When you actually measure, it could be 14. All of these, when multiplied by themselves, give you an answer close to 200. Okay, so one participant says, try 14.14. Try 14.14. What do we get?
199.
199. 199.
0.14 into 14.14. 199. 199.93.
Sir, 14.15 gives 216.
Yes, sir. Try 14.15.
Yes, sir.
14.15 into 14.15.
No, sir. 14.6.
200.222. Okay.
14.16.
Calculator.
14.16. All right. Now there are many trials for this trial and error method, but we know that it is close to 14.1 or 14.2. We know that it is close to these numbers. This theorem, which we have just, this result which we have just used, that for a rectangle, the square of the diagonal is equal to the number which I get when I add the square of each side. This is known as Pythagoras theorem. But that is not how Pythagoras actually stated it. Pythagoras said in terms of the hypotenuse of a right angle triangle. This statement in terms of the diagonal of a rectangle, this is how it is stated in an ancient Indian mathematical document called the Shulva Sutras.
Sir, I did not understand.
Yes, sir. I also didn't understood.
Let me repeat. What have we seen? We have seen that if I draw a rectangle and I draw the diagonal and I measure the sides and I measure the diagonal, then I take the square of the length of one side. I take the square of the length of the other side. I add these two numbers. And when I add these two numbers, the answer which I get is the square of the length of the diagonal. Let's look here. One side was 5, one side was 12, and the diagonal was 13. So 5 squared is 25. The other side is 12.
I didn't understand.
12 squared. This 5 here is this side.
Yes, sir. Understood now. Okay.
Okay? This 12 is this side. So 5 squared is 25. 12 squared is 144. I add the two, I get 169. If I measure this length, and I take the square, I also get 169. Let's take this rectangle here. One side is 4, the other side is 3.
Understood, sir.
I take the square of this side, that's 16. I take the square of this side, that is 9. I add the two, 16 plus 9, I get 25. I take the length of the diagonal, which is 5, and 25 is just the square of 5. No matter what rectangle you draw on your graph paper, this rule will always work. Let's try it again for a rectangle which is 3 centimeters on one side and 5 centimeters on the other side. Please draw a rectangle which is 3 centimeters and 5 centimeters and verify the rule.
Sir, on the new graph paper or on the other one, because I have space on the other one. The
If you have space in your graph paper, you can use the same graph paper. Or if you don't have space, use a new graph paper. Nandita, please say what you have done. Take the mic in your hand. Yeah, take the mic in your hand.
We get 5.9 as the diagonal.
For the diagonal.
Yes.
Okay, now verify 3 squared, 5 squared, and 5.5 squared.
3 square is 9. 5 square is 25. 34.
34. And what is 5.5 squared?
5.9.
30.
34.81. 5.9.
5.9. Okay.
So 34.81 is the
5.9
answer.
into 5.9. 34.81, which is quite close. Okay, so your answer should be between 5.8 and 5.9. Let's try 5.8.
Sir, I got 5.8.
Sir, even I
5.8 is 33.64. Right? That's also close to 34. If you do a very accurate diagram, then you would get an answer very close to 34. Okay. Now let me give you some problems for homework. The first problem is draw a rectangle with one side as 6 centimeters and the other side as 7 centimeters. Draw the diagonal and measure its length. When you measure the length of the diagonal, you will get 9.2 centimeters. So you have to verify.
So can you repeat the homework?
I will repeat it.
So what is the homework?
9.2.
Yeah, I'll just write it on the board here.
9.2 diagonal.
I got it, sir.
Draw a rectangle, one side as 6 centimeters, the other side is 7 centimeters. Draw the diagonal and verify that the length of the diagonal is around 9.2 centimeters.
Yes, correct.
Also verify whether 6 squared plus 7 squared is equal to 9.2 squared. Check that. Got it? The next homework problem.
Excuse me, sir.
Yes.
Do we have to send our homework?
Do you have to?
Send our homework.
We have to send our homework.
You can send it by email or in.
Sir, can we send on WhatsApp? Please send your email ID.
Sir, you have sent only said only one homework, right? That you have to draw a rectangle of 6 centimeter by 7 centimeter and measure its diagonals.
Yes.
Give your email ID.
I will give you the email ID.
Sir, I have the WhatsApp group, so can I send the homework on it?
Yes, you can also send your homework on the WhatsApp group.
You can send it.
Okay, sir.
Okay, sir. So you're on
Navnirmiti Eduquality. You can go to the Google and get the website. Navnirmiti Learning Foundation.
विवेक सर आवाज नाही येते तुम्ही काय बोलताय विवेक सर तुम्ही काय बोलताय आता आवाज नाही येते
Can you hear me?
Yes, sir. We can hear you.
So there are 3 organizations which are coming together to form this Everybody Can Do Math Collective. And you can send your homework to any of these organizations. One is Navnirmiti Eduquality. Go to the website and get the email address from there. The second is Navnirmiti Learning Foundation. Go to the website, get the email address from there. And the third is Eduquality. Eduquality is in Mumbai, Learning Foundation is in Pune, and Eduquality is in Guwahati, Assam. So you can send your queries and your homework to
Yes, sir.
any of these organizations. So that was the first homework problem. Now the next homework problem. The next homework problem is find the square root of 300 by the method which we have showed you. You know how to get it? For 200, find the square root of 300. And then again, find the square root of 400. One is very easy. One is not so easy. So you know how to do 200?
Sir, 200 also.
How did we do 200? Recall. Divide 200 by any number.
Method.
See the answer.
Sir, we have to do 200 also.
200 you have done.
Okay, sir.
200 you have found that the square root is 14.1 or 14.2. That you did. Repeat the same thing for 300 and 400.
Okay, sir.
Okay? So that is homework number 2.
So can you repeat?
Find the square root of 300 and find the square root of 400. One is very easy. One is a little less easy. But using the method that we have used in the workshop today, find the square root of 300 and 400. And you can use this method for finding the square root of any number. And the last piece of homework, draw a rectangle with one side as 5, the other side as 12, and again verify that the square on the diagonal is equal to the sum of the squares of the sides of the rectangle. Now let me summarize what we have done today. Today, we have learned about plotting points on graph paper. Now actually, if you look at your syllabus, Plotting points on graph paper is something which happens mainly in class 9 and class 10. But we're doing it here because it is very useful in class 6, 7, and 8. The second thing that we did was to study about squares and square roots using our calculator. We saw that we can take the square root of a number like 200 and get the answer as not a whole number, but a decimal fraction. We have not yet studied fractions and decimals. So here too, we were going a little ahead. And after a couple of weeks, we will be studying fractions and decimals in detail, and we will understand this much better. And then finally, we learnt about this theorem, a very important theorem called Pythagoras Theorem, which is the length of the diagonal in terms of the length of the sides. I will request you as homework to also read about the Shulva Sutras in Wikipedia and also learn about the Babylonian mathematics, which may be even more ancient than the Shulva Sutras. The same theorem was there in Greece, Pythagoras. It is there in our ancient mathematical documents like the Shulva Sutras, and it is there in the ancient Babylonian mathematics. Babylonian mathematics is from that part of the world which is today called Iraq and Syria. So whether it is Iraq and Syria, or whether it is our part of the world, or whether it is Greece, in fact, even in China, Pythagoras theorem was known in a different form. All the forms are a little bit different, but they all have this in common. The mathematics is very similar, because even in those ancient days, perhaps, there was a lot of exchange between the cultures in Mesopotamia, Babylon, the culture of the Indian subcontinent, the culture of Greece and Europe, and the culture of China. So I request you as homework to also read about this in Wikipedia, because it is a very exciting exploration of the history of mathematics. Now I will conclude here the presentation, but we will take questions from anybody who would like to raise some questions.
Sir, I wanted to.
Yeah.
So I just wanted to know that in the chat they have put links. What we have to do in that link?
Hello? Yeah, we have shared the link for feedback form. So you can click on that link to give the feedback of the session, today's session.
Okay.
Yeah. And also, hello? No. I'm also sending an email ID and a WhatsApp number so that you can forward your homeworks on the chat. So I'm sharing the email ID and also mobile number on the chat. Hello? Yeah.
Yeah.
Other than that, are there any other questions from the participants regarding the session?
No.
I have a last question.
If
Very important.
Excuse me, sir.
Yeah.
Will there be more sessions like these?
Oh, yes. Every week.
Okay, sir. So,
Every week on Saturday.
keep getting the links for this session.
Yes, please note the link. And also, if you enjoyed the session, please inform your classmates and your friends and ask them to also join the Janaganit program. And as my colleague Varsha,
Sir, your voice is echoing.
my voice is echoing. Yeah, as my colleague Varsha has told you, please submit your comments and your suggestions on the feedback form. Your feedback is very important. Would you like the session to be at some other time? Is this time convenient or not convenient? Would you prefer some other time? Would you like some subjects to be dealt with in these sessions? How you would like us to interact with you? All your suggestions are very important to improving this program. Today's program, it has been viewed all over India, and not only in India, but there are some participants from abroad. And we would like to improve with your suggestions. The basic thing which I want to emphasize here is that every participant should understand everything that we have done in this session. And you will understand everything if you do the problems that we are posing in these sessions. If you are only listening, you will not understand. But if you are solving the problems with pencil and paper and materials, then you certainly understand. So in the future sessions also, please come ready with the materials. We will inform you in advance what you need to bring. So please come with those materials and use those materials which we will tell you in advance to solve the problems that we will be posing in the session. This is not a lecture. This is only a guidance for problem solving. You are doing the problem solving. We are only guiding you in the process of problem solving. So I hope you enjoyed and understood what we have done today about Pythagoras Theorem. Thank you again, and bye.